Hello, this is the second video of the second Sequences and Series section on the Maclaurin series for OCR Pure Core Further Mathematics. This video will look at the general Maclaurin series. We've seen how a polynomial of the form px, as shown here, can be used to approximate a function f of x by finding the coefficients by evaluating the function and its derivative at the point x equals 0. The textbook gives more details of this derivation. This approach can be generalized as follows, where f of x equals the value of a function at 0 plus the value of the first derivative divided by 1 factorial and then multiplied by x, plus the value of the second derivative at x equals 0 divided by 2 factorial and then multiplied by x squared, and so on. This is called the Maclaurin series of f of x. It could also be called the Maclaurin approximation or expansion. We can use this series to approximate a function provided we can work out the values of all the derivatives. If this series, which is an infinite series, converges to a limit, then it converges to f of x. Some Maclaurin series are only valid for a certain range of x values, and we will look further at validity when we look at the Maclaurin series for standard functions in the next video. In this example, we are asked to find the first three non-zero terms and then also the general term for the Maclaurin series for f of x equals to cos 2x. Here we can see that f of x was cos 2x, so that the function value at x equals 0 was 1. The derivative is minus 2 sine 2x, and as sine of 0 is 0, then that value there is 0. Differentiating would give us minus 4 cos 2x, and accordingly a value of minus 4 at x equals 0. We would then get minus 8 sine 2x and a value of 0. And you can see that all the odd derivatives are going to be 0. And then a value of 16 cos 2x, the fourth derivative, a value of 16. Hence, if we look at the first three non-zero terms, that will give us 1 minus 4 over 2 factorial x squared plus 16 over 4 factorial x to the power 4, which we can simplify down to 1 minus 2x squared plus 2/3 x to the power 4. In order to find the general term of the Maclaurin series, let's move further on down the table. The sixth derivative would be minus 64 cos 2x, and a value of minus 64. We notice that in order to account for the positive or negative, we could look at minus 4 to the r cos 2x for the 2rth derivative, rather than using the 2. And that would then be a value of minus 4 to the r. Therefore, the rth term will be minus 4 to the r over 2r factorial x to the 2r. Here we have a dynamic GeoGebra file to show you the function f of x equals cos 2x in green and the approximation being used in red. So here we are just taking it to the x squared term. This is what it would look like if we take it to the x to the 4 term, which is what we've just looked at, the first three non-zero terms. Here, if we add that fourth term, again, look at the range of x. Note that x is in radians on this graph, over which the approximation fits the actual function quite well. Up to 8, 10, 12, 14, and so on. And look at the associated terms in the approximation. In the next video, we will look at the Maclaurin series of standard functions.